Changing tomorrow. Exploring the infinite potential of 3D and 4D printing. At the point when previously created during the 1980s, 3D printing appeared to be an out thing of sci-fi. However, lately, 3D printing, or added substance fabricating, has bounced in fame. Creators of everything from adornments to biomedical gadgets have accepted its capacity to print three-dimensional articles rapidly and monetarily from all assortment of materials going from metals and elastic to chocolate and living cells. Today, industry and scholarly analysts keep on investigating approaches to upgrade and adventure this refined innovation. Sooner rather than later, forward leaps, for example, 3D printed houses, plant-based meats, and lightweight 3D printed vehicle and plane parts are probably going to get typical. The 3D printing measure itself is genuinely clear. Working from an advanced record, the 3D printer layers materials going from metals to plastics to fabricate three-dimensional items. Hydrogels, which stay strong regardless of having 70% water content like our body, are among the 3D printed objects being created by my research facility at Rutgers University School of Engineering. These brilliant materials can distort themselves swell or psychologist in light of outside improvements like temperature or electric fields. While hydrogels have for some time been essential for our regular daily existence, present in everything from disposable diapers and jello to contact focal points and bosom embeds, these keen gels plainly highlight the future when they meet 3D printing. Envision a human-like, 1-inch tall, 3D printed hydrogel that can walk submerged and get and move objects when enacted by power. It might sound far-fetched, yet it's definitely not. We have made a hydrogel that does exactly that, and that offers colossal potential for clinical advancement since it intently takes after delicate tissues in the human body that contain bunches of water and pass through little atoms like medications. This implies that moving shrewd gel could prompt the improvement of counterfeit hearts, stomachs, and different muscles just as delicate mechanical gadgets for diagnosing sicknesses and conveying drugs. Time is the fourth measurement in 4D printing that allows us to make keen, adaptable, lightweight and beforehand unbelievable materials that can change shape and transform from being pretty much as firm as wood to be delicate as a wipe. It is because of the inventive marriage of 3D printing and shrewd materials that 4D printed objects can change shape and property when they are set off by temperature or other natural elements. Presently, 4D printing empowers printed objects to detect the climate and respond to it, very much like we generally do. For instance, metamaterials, from the Greek word meta, which implies higher or past, are counterfeit materials designed to have illogical properties not found in nature. Be that as it may, in spite of the boundless potential, the shape and properties of metamaterials are singularly set whenever they are fabricated. Yet, with 4D printing, we can transform them with heat, so they can promptly transform from being unbending to adaptable and back once more. When presented to warm, these metamaterials' inflexibility can be changed more than 100 overlay to control stun ingestion. They can be perpetually molded and reshaped and returned on request to their unique shapes when warm. 4D printing's remarkable interchange of materials science, mechanics, and 3D printing makes certain to make another pathway to a scope of energizing applications that will improve innovation, well-being, security, and personal satisfaction. Later on, shape-moving plane or robot wings could help improve streamlined execution, while delicate robots made out of adaptable, elastic-like materials could be custom-fitted to work in testing conditions. 4D printing can likewise assist with making little, graceful biomedical gadgets which could in the long run be less horrendously embedded in individuals for demonstrative or medication conveyance purposes. Moreover, 4D printing may likewise assist us with reacting future scourges all the more rapidly by giving another device to speed up the speed of developments in drug labs. However, 4D printing presents its own arrangement of difficulties. Until this point in time, we have had the option to make little highlights with exact dimensional control managed by our 3D printing innovation. To keep up this exactness while making bigger articles, the issue of versatility should be tended to. Moreover, we need to think about these articles' mechanical properties. We can make every one of the adaptable, even modern fascinating gadgets and applications we need, yet in the event that they are at last to make it to the commercial center, we should resolve worries about mechanical properties of dependability, weakness, opposition, and solidness. So, we need to address the topic of how to improve them while upgrading their exhibition. At last, we need to keep on bringing our minds into play. At the point when architects plan things, we regularly will in general restrict ourselves to existing materials and assembling strategies. With these arising classes of materials portrayed by uncommon functionalities and quickly propelling 3D and 4D assembling innovations, we currently are just restricted by the extent of our minds.